Welcome back to Talk Tensors. Ready for another deep dive?
Absolutely, always excited to explore new ideas.
Today we're tackling evolution and the Knightian blind spot of machine learning.
Oh, this is a fascinating one. Really gets you thinking about the limitations we might be bumping up against in the field.
Right, like the paper argues that machine learning, for all its progress, could be missing something really crucial for true intelligence. Being able to handle a future that we just can't predict.
Yeah, the unknown unknowns problem.
Exactly.
The authors actually have a term for it, Knightian Uncertainty.
KU, right?
Yep, KU. Those unexpected events, those circumstances, we can't even imagine, let alone plan for.
Like imagine a self-driving car.
Okay.
It's been trained in, say, the desert,
Right?
but suddenly has to navigate a snowstorm.
Whoa.
It's those kinds of unpredictable scenarios that machine learning, especially reinforcement learning, just struggles with.
Totally. And the paper traces this back to the very core of RL, the Markov decision process, the MDP.
MDP.
Such a powerful framework, but it makes this assumption,
What's that?
a fixed, unchanging world.
Which we know is not how reality works.
Exactly. Reality throws curveballs all the time. New inventions, shifting environments, those black swan events.
All the stuff the MDP just doesn't account for.
And there's this other thing with RL, the discount factor in its calculations.
Okay.
Essentially, agents kind of ignore anything beyond a certain time horizon.
Like short-sightedness built right into the system.
Exactly. They're focused on immediate rewards, almost blind to the long-term consequences.
So they're missing the big picture, the potential for drastic change.
Yeah, it's like driving with blinders on.
Great analogy.
To understand how to maybe address this, the paper does this fascinating comparison between RL and get this biological evolution.
Evolution. I mean, that's the ultimate learning algorithm, right?
Been fine-tuning life for billions of years.
And it's produced some amazingly resilient creatures,
Think about those zebra mussels thriving in the Great Lakes.
even though they evolved over in Europe.
Completely different environment.
It's a level of robustness that our machine learning systems haven't quite cracked yet.
Not even close. So the question becomes, what's evolution's secret? How does it handle those unknown unknowns, you know?
Yeah, how does it prepare for stuff it can't even anticipate?
Well, unlike RL, evolution doesn't use complex equations or models.
Huh, interesting.
It's more like it throws out a ton of variations, experiments, and
Yeah.
lets the environment be the filter.
Survival of the fittest.
Exactly. The failures get weeded out, the ones that survive, their traits get passed on.
Ensuring that long-term resilience.
It's like a constant experiment, nature selecting the most adaptable solutions over millions of years.
And it works. So no fancy calculations, just trial and error at a massive scale.
And importantly, evolution isn't stuck with one approach.
What do you mean?
It's constantly generating diversity, new body plans, behaviors, all sorts of survival strategies.
So it's always testing its creations against whatever the world throws at them.
Right. One species evolves a new trait and suddenly everyone else in that ecosystem has to adapt.
A never-ending game of adaptation and survival.
Exactly. And that's the kind of open-ended, always evolving environment that RL, as it stands now, just can't quite replicate.
So what do we do? Are we saying machine learning should ditch all those fancy algorithms and just copy evolution?
Not quite, no. I mean, the authors aren't saying we should completely abandon RL.
Okay, good.
It's more about, like, drawing inspiration from evolution.
To fix that Knightian uncertainty blind spot.
Exactly. So there are a couple of really intriguing avenues they point to.
Okay, I'm all ears.
One is getting insights from this field called artificial life.
Artificial life.
Yeah. You basically create these simulations, like virtual worlds,
Okay.
and you let digital organisms evolve in those environments.
So instead of waiting millions of years for evolution to play out in the real world, we can kind of fast forward the process.
Precisely. We get to observe how these digital life forms adapt to all sorts of crazy challenges.
And hopefully uncover some strategies that we can then apply to machine learning.
Exactly. It's like peeking into evolution's playbook, you know?
Very cool. So it's like fast forwarding evolution to learn its secrets.
Right. And then the authors talk about this other idea, open-endedness.
Open-endedness. What does that mean in this context?
So imagine an algorithm.
Okay.
It doesn't just learn to solve the problems we give it.
Right.
It actually generates new problems for itself, more complex ones.
Wow.
It's constantly evolving, pushing its own boundaries.
It's almost like how science or art never really stop evolving, always pushing into new territory.
That's a great way to put it. So instead of passively learning from the data we feed them,
These algorithms would be creating their own learning challenges.
Exactly. That kind of self-driven evolution could be huge EE for breaking free from like static data sets and fixed goals.
It changes how we think about machine learning entirely.
It really does. It's not about passive learners anymore.
It's about active explorers, constantly seeking out new challenges.
And that aligns perfectly with the paper's main argument.
Which is?
To get to true intelligence, we got to move beyond just optimizing for specific tasks.
Got to think bigger.
Right. We need systems that can thrive in these open-ended, unpredictable environments.
Embrace the unknown.
Exactly. Give our algorithms that same kind of adaptability, that resilience we see in nature.
So not just mimicking evolution directly, but taking inspiration from its core principles.
Exactly. And that might even mean going back and rethinking the very foundation of RL.
Whoa, really?
Yeah.
Yeah.
Can we build mechanisms into RL agents so they can recognize when they're facing a KU situation?
That's fascinating.
Can we incentivize them to learn how to learn, to become more adaptable when things get weird?
It's like we're being challenged to redefine what intelligent even means for a machine.
I know, right? It's not just about high scores on some benchmark anymore.
It's about navigating the real world with all its messiness and surprises.
This paper really throws down the gauntlet, you know?
It does. It's given us a lot to chew on.
Yeah.
But I gotta ask, are these ideas, the artificial life, the open-endedness, are they actually practical? It's super exciting to think about all the possibilities, but also kind of daunting. It's like a huge EE shift in how we think about AI.
Yeah, it is a big shift, but I think like a necessary one, you know?
Like where we are now.
This focus on narrow tasks, these controlled environments.
It's gotten us pretty far.
It has, but
Yeah.
we're hitting those limits, right?
Totally. If we want to get to truly intelligent systems,
Systems that can solve these complex, messy, real-world problems.
we got to embrace the unknown.
100%. And this paper does a great job of highlighting those limitations, right?
It really does.
It's not just about like bigger models, more data.
It's about a deeper understanding of what intelligence is.
Yeah. One that like accepts that change is inevitable.
Anticipates it even. So I'm thinking about our listeners.
Yeah.
A lot of them are probably working on RL systems right now.
Makes
What's like one key takeaway they should consider in light of this whole Knightian uncertainty thing?
I'd say, don't just optimize for what you already know.
The known knowns.
Right. Think about how your system's going to handle stuff it's never seen before.
The curveballs, the black swan.
Exactly. How can you build in mechanisms that encourage, like, exploration, adaptation, constant learning?
It's almost like giving our algorithms a sense of curiosity, right?
Yes, a thirst for the unknown. And also a good dose of humility, I think.
Humility.
We got to admit that we can't predict everything.
Our models are going to run into stuff they weren't prepared for.
For sure. So it's not about eliminating uncertainty.
It's learning to thrive in spite of it.
Exactly. Who knows, maybe by embracing this Knightian uncertainty,
Yeah.
we might stumble on solutions, innovations, stuff we'd never dream of in our nice, neat little paradigms.
This has been fantastic.
I know, right?
A deep dive into a topic that's like intellectually stimulating, but also so relevant to where AI is headed.
Couldn't agree more.
Thanks for guiding us through all this.
My pleasure. Always a good time. And for all our listeners out there, as you keep exploring machine learning, keep this challenge in mind. Knightian uncertainty.
Don't forget it.
Don't be afraid to question those assumptions. Try new things. Think outside those boxes, those paradigms.
Love it.
The future of AI might just depend on it. Our ability to handle the unknown, build systems that can thrive in this world of constant change.
Truer words have never been spoken. Thanks for joining us on Talk Tensors, everyone. We'll catch you next time.